Hello dear friends. In this session, we will be looking into hashing techniques. What is this hashing? You can just look at this small example from Wiki. There are some set of keys and you have a hash function. Whenever you apply this hash function on the key, you will be getting a hash, some address kind of thing, and there you can store some data which is related to this key. You can see Lisa is hashed to hash 1 and Sam is hash 2 hash 4. Likewise, hash has some kind of ordering, but you can see some problems sometimes. For example, John and Sandra are getting into hashed to hash 2. So this is called as a collision. If you get a collision like this, you can have some collision resolution technique such as storing or accessing data from the next bucket. Likewise, we can see all these things as hashing techniques, and we will see each of the stuff, what it is, how it is useful. Likewise, the first one, hash function. Hash function is also called as randomizing function, and it will be applied to a hash field value of a record. You will be having a record, and to the particular field of that record, you can apply hash function. And when applied, it will yield address of disk block where you can store the record. So, entirety. Hashing technique is to improve the performance of storage or retrieval of records. The organization which includes hashing is called as hash file. There you can create a file which works based on this hashing, and search condition is dependent upon a hash field, and hash field is usually key field, and hence we can call it as a hash key. And hashing can also be used as internal search structure, and records can be organized likewise. There are two varieties of hashing, internal hashing and external hashing. In the internal hashing, you will maintain a hash table. In the external hashing, it is more based on the files and directory oriented access. Whereas in the internal hashing, you have a hash file, hash table, and accordingly you will access data from the table, from the file. And at times, it may happen that different keys may yield into a single hash, and that is called as hash collision. Now, what to do? You can apply some collision resolution strategies. According to this strategy, there are three strategies listed here. According to this collision resolution strategy, you can allocate next subsequent location which can be accessed easily, or which can be a decent replacement for the collided location. Some of the collision resolution mechanisms are like this. Open addressing. If the current location is filled, you may use the next free location. Chaining is another strategy where if the current location is being filled, you will link to next location where you may find the searched record. And you can also apply multiple hashing. If there is a collision, we need to repeat the hash function application. It could be same hash function or different, but we need to repeat hashing. You can see some example of internal hashing. You will be having a huge array, or this is the space for hashing, and at times you may have some collision, right? So this is how the data fields will be stored. The data fields different records, and at the end you will be having a overflow pointer. For instance, if the current location is free, or if there is no overflow, then there will be a -1 at the end of the data fields. If there is a overflow, then at the end you will find a address where you can find the subsequent data fields or subsequent records. For instance, uh, once you get into the field 1, if you don't find required data values, then you should go to location M, which is a overflow pointer, and at the location M you will find the subsequent part of that record. And even at this location M, if there is a overflow, you need to have another overflow pointer which will point to some other location. There you will find subsequent records. Likewise, here the first part is called as address space and the next part is called as overflow space. So when the address space gets a overflow, you will go to overflow space. You will link to overflow space. So here this table is being mapped into this kind of hash space. So another hashing technique is external hashing. In the external hashing, you will be using disk files, and the target address space is made up of buckets, and each bucket is a collection of disk blocks, usually which is contiguous. At least one or more disk blocks will be there in a bucket. Hash function maps a key into relative bucket where the record might be available, that bucket. And table in the header of file will convert bucket number into disk block address, and hence you can map any key into disk block address. Collision problem is less severe with buckets because usually buckets are larger, but very large bucket size might reduce efficacy of searching or hashing, and hence we need to manage it in a decent way. One example of external hashing is static hashing, where fixed number of buckets are allocated. We'll see some examples. This is how disk space is divided into buckets. And here you can see overflow handling for buckets. Here this is bucket 0, bucket 1, bucket 2, so on. And when a bucket has space, you can directly insert records into that particular bucket. But when a bucket is being filled, there is a overflow, and the record pointer, instead of pointing to null, record pointer will point to a overflow bucket location, and this overflow bucket will contain subsequent records. And if there is a overflow here also, then this overflow bucket can be connected to next bucket, and there you can put the subsequent records. And you can see a difference. A normal bucket will be having different records, and at the end it will have a record pointer. But usually overflow buckets will differ, and each record might be allowed to have a overflow record pointer. And there are some other varieties of hashing, and which is essential when the database or files are being expanded. And these kind of hashing techniques are known as dynamic file expansion, and they are given names like extendable hashing, where file can grow and performance will not be degraded. And there are some other techniques such as dynamic hashing, where a treat structured directory is maintained, and linear hashing, where a hash file can be expanded or shrinked without requiring a directory. So this is about storage devices and different techniques to improve storage performance of a database. And We will get into practical query part in the next unit. And till then, happy learning. Take care.